In this video, we'll explore the side, 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 and side, angle, side triangle similarity postulates. We'll start with side, side, side. If the corresponding sides of two triangles are proportional, then the triangles are similar. So we want to look at the ratio of corresponding sides between two triangles. And we have to look at all three sides. Let's start with the ratio of, we'll go small triangle to big triangle, and we'll look at the longest sides. So side SU is to side PR. That simplifies to 1/2. Now let's look at the base of these triangles. Side TU is to side QR. That also simplifies to 1/2. So far, this is looking promising. If the last pair of sides simplifies to 1/2, then we can conclude these triangles are proportional. So let's look at the ratio of side TS to side QP. That also simplifies to 1/2, so we can conclude triangle PQR is similar to triangle STU by side, side, side. Here's an example where you're asked to determine if these triangles are similar. Let's look at the small triangle over the big triangle, and let's look at the shortest sides. So side DE, compare that to side AB. That's 4/6, which simplifies to 2/3. So if the ratio of the other sides is also 2/3, these triangles will be similar. Let's look at the longest sides in the two triangles. So side FD over side CA. That's 8/12. I can divide both of those numbers by 4. 4/4, giving me 2/3. And then the remaining sides, side EF over side BC. 6/9 also simplifies to 2/3. Therefore, we can conclude these triangles are similar. Triangle ABC is similar to triangle DEF. Here's another example. We are given two triangles which look similar. One looks bigger than the other. And we are asked to determine if, in fact, they are similar. So we can look at the ratio of the shortest sides in the two triangles, the longest sides, and the remaining sides. We'll start with the shortest sides. Let's look at KL over ST. That ratio is 5/9. Now we'll look at the longest sides, JL over RT. And this fraction does not equal 5/9. Therefore, no need to even look at the remaining sides. We can conclude these triangles are not similar. So now let's move on to side, angle, side. If an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides that include these angles are proportional, then the triangles are similar. So here's our example. We can see automatically that the two angles are given as congruent. So what we want to look at is the ratio of the shorter sides, and then look at the ratio of the longer sides. If those ratios are equal, these triangles are similar. So the ratio of the shorter sides, let's do this time DF over AC. That's 5/3. Now the longer sides. 10/6 simplifies to 5/3. And of course, the angle in between is congruent. So we can conclude that triangle ABC is similar to triangle DEF by the side, angle, side similarity theorem. Okay, are these triangles similar? Well, when you have a situation like this, it's a good idea to redraw your diagram and pull that little triangle VWX out and draw them separately. Now let's look at, we know that angle V is congruent to itself, right? So there's my pair of angles, but let's look at the ratio of the longer sides. Let's look at XV compared to ZV. So that is going to simplify to 1/3. Now let's look at the ratio of the shorter sides. VW over VY, that's 4/12, which also simplifies to 1/3, plus the angle, of course, that they share, angle V is congruent to itself. So we can conclude then that triangle VWX is similar to triangle VYZ by side angle side similarity. Here's another example. It is not obvious that there is a pair of angles that is congruent, but when you think about that angle that touches, the angle D in each triangle, because of the vertical angle theorem, we know that these angles actually are congruent. So let's test the ratio of the longer sides. Let's do side DM over side DF. That's 25 over 30, which simplifies to 5/6. Let's look at the ratio of the shorter sides. DN over DE, that's 15 over 18, which also equals 5/6, plus the angle that D in each triangle is congruent because of vertical angles. Therefore, we can state that triangle MDN is similar to triangle FDE by side angle side similarity theorem. Furthermore, if somebody asked us for the scale factor from triangle MDN to triangle FDE, because it's getting bigger, you want a scale factor greater than 1, so we're going to have 6/5 as our scale factor.